Let us now discuss the Gauss law for magnetic field and also express it using the del operator to obtain the Maxwell's equation. So let us now see the statement of what is the Gauss law for magnetic field. For this, consider one magnetic field here, like we shown the magnetic field B bar. So B bar here is the magnetic flux density, which can be written as B bar is equal to mu H bar, where H bar is the magnetic field vector and mu is the permeability of the medium. So in such a magnetic field, let us consider one closed surface like this. You can imagine any closed surface like sphere or any other closed surface. Here I have taken a cubical closed surface. Now the statement of the Gauss law says that the total flux passing through all the surfaces of this closed surface or the cube is equal to 0. So mathematically we can write it as the closed surface integral over the surface of this cube of B bar dot ds bar is equal to 0. So here B bar dot ds bar gives us the flux passing through the surface. So if I add the flux passing through the surface over all the 6 surfaces of this cube, the net flux is equal to 0. So this is the Gauss law statement in mathematical form, in integral form. Now let us write this using the Gauss divergence theorem. So here we can write this closed surface integral into the volume integral using the Gauss divergence theorem. So according to which now it is closed surface integral of B bar dot ds bar is equal to the volume integral of divergence of B bar dV. Now therefore we can write from the equation 1 and 2 that the divergence, the volume integral of divergence of B bar dV is equal to 0, or we can say divergence of B bar is equal to 0 at each and every point inside the cube. Or if you write B bar in terms of H bar, mu H bar, then also you get divergence of H bar is equal to 0. So this is known as the Gauss law of magnetism in the differential form or point form. So here this equation is known as the Gauss law in integral form. What is the meaning of this? So we have learned in the magnetism that there is no source or sink in the magnetic field. So always the flux, the magnetic flux is going from north pole to south pole in a rotational manner. There is no one source or sink like we find in the electrical field. In electrical field we can find positive charge as the source or negative charge as the sink, like that. But in the case of magnetic field we always find north pole and south pole together. The magnetic flux originates from the north pole and reaches the south pole in a rotational manner. Therefore there is no source or sink in the magnetic field, or magnetic field is said to be solenoidal type.